The problems will go in this way. We'll see for the problem. Your question is solve x square d square minus 4xd plus 6 of y, it's equals to x square. See, by seeing this equation only, you have to make it out that you have to solve this equation by using the homogeneous, that is Euler's Cauchy's terms. Here you would see the d is there along with x. Till now you have seen the method, it's only single d, only d was there. With that d there was a no suffix, nor there is a no prefix was there. But here what is there? Along with the d, x term is there. When it is in the form of x into d terms, you have to move by this method only. That is Euler's Cauchy's linear equation. So solution, where we know that you're going to write, we know that x is equals to e to the power of z, and z is equals to log x, and your x d, it's equals to theta x square into d square, which is equals to theta of theta minus 1, because I'm having here only two terms, x square d square I'm having, x into d I'm having. Now what I'm going to do, I'm going to substitute all these values into the given differential equation what they have given to x. So it will get changed to your x into d square, it's going to be theta of theta minus 1 minus 4 x into d, that is simple theta, then plus 6 of y, it's equals to, where your x is equals to e power z whole square, where your theta stands for differentiating with respect to z by dz. Now multiply your theta into theta, it's equals to theta square minus theta minus 4 theta plus 6 of y, it's equals to e to the power of 2z. Now your theta minus 4 theta will become 5 theta, theta square minus 5 theta plus 6 of y, it's equals to e to the power of 2z. Now see this e to the power of 2z, it's got reduced into the which rule? Yes, Aditya, it's got reduced in which rule?
Rule 1. Rule
Yes,
1.
it's got reduced into the rule 1. Now see this one, the given x into d's terms, it's got changed into the simple form, that is into the theta form, where your theta is your d by dx. Now first we'll find the auxiliary equation, where your auxiliary equation m square minus 5m plus 6 is equals to 0, where your y cannot be equals to 0. So you are making that equation is equals to 0. Now this one you can write it into as, you can split this as, here constant we are having 6. So this 5m we can split it as 3m, and 2m we can split. So this is going to be m square minus 3m minus 2m plus 6, it's equals to 0. From the first two term, m is common, m of m minus 3, then from this 2, its minus 2 is common, m minus 2, it's equals to 0, m minus 2, m minus 3, it's equals to 0, m minus 2 is equals to 0, or m minus 3, it's equals to 0, m is equals to 2, m is equals to 3. So your roots, what you got the roots, where m values is equals to 2 comma 3. The roots are real and different. The roots are real and distinct, where your complementary function y suffix c is equals to c1 e to the power of m1 into z. Here we are dealing with the z. Later we will replace what is our z. Then plus c2 e to the power of m2z. Y suffix c, it's equals to c1 e to the power of 2z plus c2 e to the power of 3z. Keep it like this only. After writing our CF, we'll make the changes. Now we'll go for finding our PI. Next, to find PI. PI, it's equals to 1 by f of theta here into your phi of x, which is equals to 1 by what it was? Theta square minus phi theta plus 6. Theta square minus 5 theta plus 6 into e to the power of 2z. Now you have to substitute every theta, it's equals to a is equals to 2, which is equals to 1 by 2 whole square minus 5 into 2 plus 6 e to the power of 2z. So it's a what? It's a case of fails. You're not going to write as an infinity. It's got the case fails, which your denominator part, your f of theta, it's becoming 0 after substituting a value. 4 plus 6 is equals to 10 minus 10, it's equals to 0. When the case fails, what you have to do? You have to
Multiply by
multiply.
x and
Yes,
differentiate.
but here we're dealing with the z. So you're going to
Yes,
multiply
ma'am.
with the z. Yes. Multiply numerator with z and differentiate denominator with respect to theta, not d here. With respect to theta. एक मिनट बेटा. It's equals to 1 divided by 2 theta minus 5 e to the power of 2z. Where your theta square differentiation, it's equals to 2 theta and theta. And your theta differentiation, it's equals to 1. So it's going to be as an 1 by 2 theta minus 5 e to the power of 2z. Again we will substitute. Theta, it's equals to a is equals to 2, which is equals to 1 divided by 2 into 2 minus 5 e to the power of 2z implies 1 by
Ma'am, we do
4
multiply by z
minus
here.
5. Sorry, z I have right here. Thank you. Z should be there. Z, then e to the power of 2z, which is equals to 1 minute beta minus z e to the power of 2z. Your pi is equals to minus z e to the power of 2z. Now write your general solution. Where your general solution is equals to complementary function plus particular integral y is equals to y suffix c plus y suffix p. Y is equals to c1 e to the power of 2z, then plus c2 e to the power of 3z, then minus z e to the power of 2z is your pi. Where what we have taken our x is equals to e power z. So this you have to replace into the x now. Where your y is equals to c1 x square, then plus c2 x cube minus where z is equals to your log x into x square, which is your required solution. Yes, Aditya, any doubt over here?
No, ma'am.
It's a clear.